Welcome back to section 8.1, part 3. So here we're going to be looking at more examples using the sampling distribution for X bar. Let's look at example 2. The weights of pennies minted after 1982 are approximately normally distributed with mean of 2.46 grams and standard deviation of 0.02 grams. Right, so that's the information they give us. So I'm going to go ahead and write that down before I even start the problem part A. So let's see what the problem's about. So this is about weights. So again, this is going to be the variable of interest. It says the weights have approximately normal distribution with mean of 2.46 and a standard deviation of 0.02. So I'm going to go ahead and write down that info over here on the side. So this is about weight, so that's going to be the distribution. So population distribution, this case of weights, which is our X. It says we do know the shape, it is normal. We know the mean, which is 2.46, and we know the standard deviation of 0.02. Okay, so that's the information they give us. So let's see what part A says. What is the probability that a randomly selected, randomly selected penny weighs less than 2.40 grams? So this problem says, again, probability that a randomly selected penny. So A means only one. So here we don't have a sample necessarily. So then this problem wouldn't be about X bar. It's just about that one penny having a weight. See, it's just weight, which is just X, less than 2.40. So this is not about X bar. This is just about the weight of just one penny. So here we only have to use this distribution for the weights. Okay. So we know that they're normal. So let's draw a normal curve. The mean is at 2.46 and the standard deviation is at 0.02. So we want an X of less than 2.4. So 2.4 is right here on the left hand side. 2.40, and we're looking at less than, so that will be the area on the left hand side. Therefore, the probability that the weight of the one penny, so X, is less than 2.40 grams is found by, since we're having probability under a normal curve, normal CDF, we're going towards negative infinity, so negative 1 E99, upper bound of 240, mean of 2.46, and standard deviation of 0.02. So this, you punch this into your calculator. Let me go ahead and do this time in my calculator. Right, so here's the calculator. So we're going to do, go ahead and clear it out. Second bars, normal CGF, negative towards negative infinity. So we have a negative 1. And then remember that the E for scientific notation is this double E here above the comma. So second E, 99, comma. Then we were going up to 2.40 with a mean of 2.46 and a standard deviation of 0.02. Close the parentheses. So then we get 0.0013. So we're looking at 0.0013. This is going to be our final answer. So this will be the probability that one randomly selected penny weighs less than 2.40 grams. Let's go part B. If a random sample of 10 pennies is obtained and the weight of each penny is recorded, describe the sampling distribution of the sample mean. All right, so now we have a sample of 10, and this problem's asking for what would be the distribution of the sample mean. That means the distribution of X bar. Right? So sampling, so we're just describing, we're not finding a probability. Remember that when we describe a distribution, we have to describe three things: the shape, the center, and its spread. So for the shape for X bar, we need to look back at, so here the sample size is only 10. So we need to have the distribution for just the individual weights to be normal, which we know it is normal, right? And so that's going to help us determine that the shape of X bar is also normal. So if it's normal to begin with, it just stays normal. The center is described by the mean, this case of X bar, which we know is the same as the mean of the population, which is 2.46. And the spread is described by the standard deviation. So in this case, the standard deviation of X bar is the standard deviation for the population divided by the square root of n, which in this case is 0.02 divided by the square root of 10. And again, I'm going to leave it in an exact form. And that would be part B. Let's look at part C. What is the probability that in a simple random sample of 10 pennies, the mean weight is at most 2.465 grams? Right, let's read this part again. What is the so now we're looking for a probability that a simple random, so now we have a sample of 10 pennies, have a mean weight of at most 2.46 grams. So now we have a sample of size 10, and the problem is about the mean of those 10 pennies, so that means X bar, being at most. So at most has to be less than or equal to, and then the 2.465. So then this problem isn't about just the individual weights, it's about the mean of the 10 weights, of the 10 pennies. So now this problem is about X bar, so we're going to be using the distribution for X bar. So let me scroll back here a little bit. Right. So we know the distribution is normal with a certain mean, certain standard deviation, so we're going to use that distribution. So sampling distribution of X bar. We know it's normal, so then we can go ahead and do a quick chart here. The normal curve, its mean, its center is at, for X bar, is 2.46 as we saw in part B. And the standard deviation of X bar is 0.02 divided by the square root of 10, because that's our sample size right here. All right, so here the X bar of interest is a mean, or an X bar of 2.465, so it's going to be bigger, 2.465. So I mean bigger as in bigger than 2.46. But then the area that we're going to shade says it's at most, that means less than or equal to, so we're going to shade to the left-hand side. So to find that probability that the average, that the mean weight of those 10 pennies is at most, so that means less than or equal to 2.465, we're going to do, since it's probability under normal curve, normal CDF. This is also going towards negative infinity, so we have negative 1 E99, an upper bound of 2.465, that's where our shading ends. Mean, again, this is for X bar. The mean of the X bars is 2.46. And then the standard deviation of the X bar, so it's 0.02 divided by the square root of 10. So I'm going to go ahead and try this one on the calculator also. So, clear this one out. So we have second bars, go to normal CDF. So we're going towards negative 1 E99, comma, then 2.465. Then the mean of X bar was 2.46 with the standard deviation. So in here I'm going to type what we wrote right there on the notes, which is 0.02 divide by the square root of 10. So I'm able to type the 0.02 divided by 10 directly inside here, the function. So that way I didn't have to round ahead of time. Rounding might give you sort of a round of error in your final answer. So we're just avoiding that. So we have 0.7854. So we have 0.7854. And that'll be for this problem. Let's look at one more. So suppose that the mean time for an oil change at a 10-minute oil change joint is 11.4 minutes with a standard deviation of 3.2 minutes. So that's the information we have. So this was about the time. So this is going to be our variable. We know that suppose that the mean, so we have a mean of 11.4 with a standard deviation of 3.2. So that's the information that we know. So this is about time. So the population distribution for the time has a, of course we always describe the shape. Doesn't say, so we don't know. We do have the mean of 11.4 and a standard deviation of 3.2. So again, we just summarize the information. Now let's look at the problem. If a random sample of 35 oil changes is selected, why is there no information about the shape of the population distribution needed to use the normal sampling distribution to compute probabilities about X bar? So about the sample mean. Well, we know that even if we don't know the shape of the distribution, central limit theorem says that our sample, if it's bigger than or equal to 30, then the distribution for X bar is still normal. And here the sample is 35, right? So by central limit theorem, since n equals 35, which is bigger than or equal to the 30, right? X bar still has a normal distribution. And so that's why we don't need to know what the shape is for the population distribution, because our sample size is large enough, and that guarantees that X bar has a normal distribution. All right, so let's do part B. If a random sample of 35 oil changes, so we still have the same sample size, what is the probability? So now we're looking about finding a probability that the mean oil change time is less than 11 minutes. So now it's about the mean oil change X bar being less than 11 minutes. So now we're using the sampling distribution of X bar. I'm going a little fast because I'm running out of time, but we know it's normal. Its mean is at 11.4 and a standard deviation is 3.2 divided by the square root of 35. So we want an oil change mean time of, shouldn't be X bar, should be 11 or less than that. So in this case, the probability that X bar is less than 11, again, we're finding area under the normal curve, so it's normal CDF, -1 E99, 11, 11.4 for mean, and standard deviation of 3.2 divided by the square root of 35. Punch this into the calculator, and you're going to get 0.2298. So we're still able to use the normal CDF because the solution for X bar is still normal. And this will be our final answer. And I'm going to go ahead and stop right here.